You want to learn programming? How do you do that? You search the internet, and everybody is telling you to learn object-oriented programming. Every programmer you meet is talking about object this, object that, objects, blah, blah, blah. So you ask, what the hell is object-oriented programming? But before we even touch OOP, you need to understand what code actually is. At its core, programming is just two things: data and logic. Data is the stuff you store: strings of text, integers, booleans. This is primitive data. And logic, that's the functions, the instructions that manipulate your data. In normal procedural programming, your data and your functions are completely separate. You make a variable here, you pass it to a function over there. This works fine for a simple script. But let's say you're building a video game. You don't just have one player, you have 100 enemies. Now you have 100 health variables, 100 speed variables, and a bunch of floating functions. You accidentally pass a goblin's health to the player's healing function, and everything breaks. It's a nightmare. This is why object-oriented programming exists. OOP fixes this mess by grouping the data and the logic together into a single package. The package is called an object. You no longer have floating variables and floating functions. You have a player object that holds its own health and has its own functions built right inside it. But to make an object, you first need a blueprint. That's what a class is. A class is just the code template. It says every player in this game will have a health number and an attack function. But a class isn't a real thing in your game yet. When you actually spawn a player into the game, you are creating an object from that class. Once you have your objects, OOP gives you 4 superpowers called the 4 pillars. Number 1, encapsulation. This means keeping your data safe. If your player's health is public, some random piece of code could accidentally set it to -9,000. Encapsulation lets you make the health private. The only way to change it is through the object's own approved function. Number 2, abstraction. This means hiding the complex math. When your player attacks, there might be a massive 50-line calculation for critical hits, armor penetration, and damage drop-off. But as the programmer, you don't want to see that every time. Abstraction hides the ugly logic inside the object. You just call player.attack and it handles the rest. Number 3, inheritance. Let's say you want to add a boss enemy. A boss is basically just a normal enemy, but bigger. Instead of writing all the health and movement code from scratch, you tell the boss class to inherit from the enemy class. It copies everything automatically. You just write the new stuff. And finally, polymorphism. This means many forms. Let's say you have an archer and a warrior. They both have an attack function, but when you call attack on the warrior, he swings a sword. When you call it on the archer, she shoots a bow. Same exact command, completely different behavior depending on the object. Like and comment if you want more videos. Bye.